Hello and welcome to C3 Streamland. So in the last video, we saw that if the distance between center and chord is equal, then the length of the chord is also equal. So I've retained this diagram in for the next part because we are going to make use of these two chords which are equal in length. As you already know, we have already proved that chords CD and FG are equal in length. Now I want to continue with this property that what we can do if we have two equal chords in a circle. So to start, let me just hide segments AB. So let me find where is AB over here. That's my segment AB. And let's hide segment AE because I won't need them. And let's see what we can do with this. Okay. Now, as you know that these two chords are equal, and I also want to state that whenever we try to make a triangle with any chord and the center, we always get isosceles triangle. Yeah. So let's try doing that. Let's combine these two properties and let's see what happens. So these two equal chords CD and FG, and with center A, with point A, I'm going to construct a triangle, isosceles triangle ACD here. That's my first isosceles triangle. And with segment FG and center A, I want to create another isosceles triangle AGF or AFG. Right? Now I have these two isosceles triangle. You may say, now I want to ask you a question here. Are these two triangles similar or congruent? You can write down in the comments below what you think. If they're similar, why you think they're similar. If they're congruent, why they're congruent. But that is not my focus here. In this video, I want to talk about what happens to the angle that is being created at the center. Right? Now, let's just measure angle A in both the triangles. So, I want to measure angle CAD here, which is obtuse angle 108.002. So that's approximately 108 degrees. And what about angle F, A, and G? Definitely not the external angle. I mean, let change it to an internal angle very quickly. And as you can see, both these values are same. And that is the next property for the circle, that whenever we have two equal chords of a circle and these two equal chords make equal angles with the center of the circle. So if I have to define this property in mathematical term, I will say that equal chords of circles subtend equal angles at the center. And that is the next property. I hope you understood this, and I would encourage you to explore this property with GeoGebra. Happy